Hello students, in this video you will find characteristic chemical properties of acid. Second part. First part I told you physical properties, in which you have seen nature of acid, taste, salt taste, physical state exists in both solid and liquid state, indicators effect, blue litmus turns red, acid turns blue litmus red, methyl orange pink, phenolphthalein colorless. And also I told you red cabbage juice turns green in basic medium, onion loses its smell in basic medium. All these things I have told you. Acid's aqueous solution of acid is a conductor of electricity. It is an electrolyte. Now let us see important characteristic in chemical properties. Chemical properties of acid. First, action on metals. Metals. Some metals I am writing here. Like that. This is a small series, reactivity series of metals. On moving down the series, reactivity of metals decreases. Then metals above hydrogen in the reactivity series react with dilute acid to give hydrogen gas. But speed of reaction, vigor of reaction decreases down the series. See one example. Here potassium, barium, strontium, sodium, calcium, their reaction is explosive. Their reaction with acid is explosive. Explosive reaction. Magnesium, aluminium, like that. They are giving a smooth reaction, but speed of reaction decreases. I am giving some example. Magnesium, Mg plus H2SO4 dilute gives MgSO4 plus H2. Like that, Zn plus HCl gives ZnCl2 plus H2. Like this. Then here these metals react to give hydrogen gas. Next point. Here this is part 1 with these acids, part A it was, and part B is part B. Nitric acid. Nitric acid is oxidizing agent, strong oxidizing agent. This is why when metal reacts with nitric acid, they do not give hydrogen gas, because hydrogen produced in the reaction is oxidized by nitric acid into H2O. But manganese and magnesium are metals which react with very dilute nitric acid to give hydrogen gas. Magnesium react with very dilute nitric acid to give hydrogen gas. And magnesium nitrate. Manganese react with very dilute nitric acid to give respective nitrate salt, manganese nitrate and hydrogen gas. Like this. Then they react with acid to give hydrogen. But C part you see. Other metals do not give. For example, zinc. Zinc react with dilute nitric acid to give zinc nitrate plus H2O plus nitric oxide. dilute nitric acid. This is very dilute, remember, very dilute, and here it is dilute nitric acid. You can balance the equation here by frequency method or by valency number method. 3 cross multiplication, 4 2 ja 8, 3 4H2O 2NO. And if concentrated acid react with zinc to form zinc nitrate plus H2O plus nitrogen dioxide, reddish brown gas. Then you will remember these things about other metals. Other metals do not give hydrogen with nitric acid, only 2 are there. Now reaction number 2 I am going to tell you. Action of acid on metal carbonate and metal bicarbonate. Metal carbonate and metal bicarbonate. Now see, metal carbonate and metal bicarbonate react with dilute acid to form respective salt of the acid and give out carbon dioxide gas along with the formation of water with brisk and effervescence. Then observation, remember, all carbonate and bicarbonate react with dilute acid to form respective metal salt, H2O and CO2 with brisk and effervescent. It means reaction is brisk. Effervescent means gas bubble is coming out of the reaction mixture vigorously, that is called effervescence. Reaction you see, like CaCO3 plus dilute hydrochloric acid form CaCl2 plus H2O plus CO2. Na2CO3 plus H2SO4 dilute gives Na2SO4 plus H2O plus CO2. Like that, K2CO3 plus H2SO4 gives K2SO4 plus H2O plus CO2. Some more reactions I am telling you here. NaHCO3 react with dilute acid like HCl to form respective salt NaCl plus H2O plus CO2. KHCO3 plus HNO3, any acid we can take, form KNO3 plus H2O plus CO2. Here you will remember reaction is CO2 gas comes out with brisk and effervescence. Only potassium bicarbonate and sodium bicarbonate are found in solid state, other bicarbonates exist in aqueous form. Reaction number 3, action of acid on metal sulfite. Metal sulfite and hydrogen sulfite or bisulfite. Hydrogen sulfite or bisulfite. First reaction you see. First you listen about observation. Metal sulfite and bisulfite ITE react with dilute acid to form respective metal salt of that acid, and with the release of a suffocating smelling gas, a colorless gas evolves. The smell of the gas is suffocating. It has bleaching property. It turns blue litmus red, then bleaches it. It turns orange yellow color of potassium dichromate solution to green the gas evolved turns the color green. The gas is SO2, remember. And this SO2 gas evolved in the reaction also decolorizes pink color of potassium permanganate solution. See the reaction. Here, like Na2SO3 react with H2SO4 gives Na2SO4 plus H2O plus SO2. This SO2 gas suffocating smell and turns blue litmus red, then bleaches it. NaHSO3 react with HCl. I am taking one example to form NaCl plus H2O plus SO2. Like that, K2SO3 plus H2SO4 form K2SO4 plus H2O plus the reactions which are most important, only that I am giving you. These are some important reaction you will remember. Now next is one more you see here, KHSO3 plus HNO3 forms KNO3 plus H2O plus SO2, respective metal salt H2O and SO2. Fourth reaction, reaction with metal sulfide and bisulfide or hydrogen sulfide. Then metal sulfide react with dilute acid to give a rotten egg smelling gas, hydrogen sulfide, and respective metal salt of that acid. Now that gas observation, remember, H2S, hydrogen sulfide gas evolved is colorless, rotten egg smell is there, and it turns lead acetate paper shining black. If hydrogen sulfide gas passes through lead acetate solution, there is formation of shining black precipitate of PBS. Now see the reaction. Here FeS react with H2SO4 dilute form FeSO4 plus H2S. This is very important reaction. The observation, remember, what is the smell of the gas? Rotten egg smell. The smell of the gas is rotten eggs, colorless gas, and it turns lead acetate paper. Suppose the gas is passed through lead acetate solution, then it will turn shining black. Shining black precipitate, it turns lead acetate paper shining black, or there is shining black precipitate. And here if it is passed through that, and there is formation of CH3COOH, like that. Now some more examples you can write. I have given you important one, ferrous sulfide, and the gas evolved, it turns blue litmus red and give black precipitate with lead acetate. Number 5, you can write any other example. Na2S plus HCl form NaCl plus H2S, like that, rotten egg smelling gas. Number 5, reaction with the solution of metal chloride and metal nitrate Then metal chloride, some example of barium chloride, lead nitrate, important one only I am giving here, silver nitrate solution. These solution, when barium chloride react with sulfuric acid dilute, remember, form white precipitate of barium sulfate. White precipitate, do not forget. it react with H2SO4 or HCl. There is formation of white precipitate and HNO3. White precipitate is formed there, BaSO4 and HCl, here PbSO4 and HNO3. Silver nitrate solution react with hydrochloric acid. There is formation of white precipitate of silver chloride and HNO3. Remember this. These reactions are called double decomposition reaction. There is exchange of radicals between the two compounds to form a precipitate. One of the product is solid. The reactions are also called precipitation reaction. 6 number, neutralization reaction. Neutralization reaction. This is a reaction in which acid react with base to form salt and water with the release of heat. The amount of heat released when 1 gram equivalent of an acid or base is completely neutralized. 1 gram equivalent of an acid is neutralized by a base, or 1 gram equivalent of a base or alkali is neutralized by acid. The heat released is called heat of neutralization. Now you see that one example. First I am writing here oxide, Na2O plus HCl form NaCl plus H2O. Next, NaOH plus HCl form NaCl plus H2O. Oxide and hydroxide, these are base. Some more example I am giving here, like CuO plus HNO3 form CuNO3 whole 2 plus H2O. Next, one more example I am giving here, KOH plus HNO3 forms KNO3 plus H2O. These reactions, metal oxides, metal hydroxide, in these reactions metal oxide, metal hydroxide, these are base, react with acid to form respective salt of acid and water. Next is reaction with metal thiosulfate. This was asked in ICSE exam, not this year, in the previous years. Here Na2H2O3 plus HCl forms NaCl plus H2O plus SO2 plus S. You can balance the equation. Here 2 NaCl, here 2 HCl, and equation is balanced. Now another thing is there, non-volatile nature of acid is also there. Acid react with the salt of volatile acid. For example, here reaction with metal chloride and metal nitrate Metal chloride and metal nitrate on heating with concentrated sulfuric acid undergoes decomposition to form respective metal sulfate salt with the formation of that volatile acid. Then concentrated sulfuric acid is almost non-volatile acid. It displaces the volatile acid from its salt on heating. See the example. Here NaCl plus concentrated sulfuric acid on heating below 200 degree form NaHSO4 plus HCl. But if this acid, but this is heated, if high temperature is given, heated at high temperature greater than 200 degree, then there is formation of Na2SO4 plus 2HCl, like that. And KNO3 plus H2SO4 concentrated on heating below 200 degree form KHSO4 plus HNO3. Next, if you are taking KNO3 excess and heating with concentrated sulfuric acid at high temperature more than 200 degree, then there is formation of K2SO4 plus HNO3. You will balance the equation. Now listen, these reactions are very, very important. This reaction is used for preparing HCl. This reaction is used for preparing nitric acid in the laboratory. These are very important reactions and show the non-volatile property of acid. And like that, these are some important reactions given by the acid. Acid also has dehydrating property, like sulfuric acid. If here HCOOH, formic acid, is treated with concentrated sulfuric acid, there it will decompose to form H2O plus CO. Like that, if glucose is brought in contact with concentrated sulfuric acid, then it will undergo dehydration to form black spongy mass of carbon, H2O and H2O. Now here you can balance the equation. Then this is showing the dehydrating property of H2SO4, non-volatile property of sulfuric acid. Here nitric acid, oxidizing property of nitric acid. Then that's all for today, and again next class I will tell you very interesting and important topic of this chapter. Thank you.